Hello students, welcome to CMS online classes, and this video is for class 9 chapter number 3 atoms and molecules. So in our first part we talked about atoms and its different forms and its studies. Now today we are going to talk about molecules, and already discussed in my previous class that there is a the atomic number. By atomic number, in a periodic table the elements has been arranged. So let's have a look of a periodic table. As for example, hydrogen has an atomic number of 1, so it is placed 1 first, then helium 2, okay, then lithium, barium, okay. So other elements has been placed according to the atomic number, okay. So this is the periodic table, okay. Now let's move towards our class, that means study of molecules, okay. So molecule is in general a group of 2 or more atoms that are chemically bonded together. That means atom is the smallest particles, and we study that atoms does not exist or in a free state, okay. So molecules can be seen, touch or feel, okay. So molecules can be defined as the smallest particles of an element or compounds that is capable of an independent existence. So all properties of that substance, atom of the same elements or of different elements can join together to form a molecules, okay. That means atom of the same element, okay, that means as for example, oxygen plus oxygen plus oxygen, okay, when they combine it form ozone, O3, okay. In the same way, water, hydrogen plus oxygen, H2O, water. Okay, now let's talk about molecules of an elements. The molecules of an elements are constituted by the same type of atom, as for example argon, helium, etc. Okay, as for example what I was saying you that, for example, a molecule of oxygen consists of 2 atoms of oxygen, and hence it is known as diatomic molecules, O2, okay. If 3, as I told in previously, we get ozone, O3, okay. So similarly we will talk about molecules of compounds. So atoms of different elements join together to definite proportion to form a molecules of compounds. For example, let's have an example. Water, as told in a compound, hydrogen is an element and oxygen is an element, but these two combine to form a compound, okay. Similarly, nitrogen and hydrogen combine to form a ammonia. Carbon and oxygen combine to form carbon dioxide in a ratio by mass, okay, according to the mass. That means 1 mass of hydrogen and 8 mass of oxygen combine to form what, okay. So this was all about molecules and molecules of elements and molecules of compound. Now let's have a look and what is an ion, okay. So compounds, as I already told that 2 elements combine to form a compound, okay. Compounds composed of metals and non-metals both contain charged species, that means they are charged either negatively or positively, okay. And these charged species are known as ions, not irons, it's ions. So ions may consist of single charged atom or a group of atoms that have a net charge on them, okay. So an ion can be negatively or positively charged ion, that means they are charged but negative or positive, okay, negative or positive. So a negatively charged ion is called an anion, negatively is called anion, and positively charged ion is called cation, okay. So we will take an example of sodium chloride. Its constituent particles are sodium ion and chlorine ion. So in sodium we have a positively charged ion, and in chlorine we have a negatively charged ion. That's why salt is a good conductor of electricity. Okay, so let's move to the another page. Okay, so as I told that chlorine ions are negatively charged ion. So a group of atoms carrying a charge is known as polyatomic ion. We have a table here. Okay, so we shall learn more about formation ion in our next class. Okay, so calcium oxide, calcium plus oxygen, magnesium sulfide, magnesium and sulfur, sodium chloride, sodium and chlorine. It's chlorine, but due to its charged particles we write chloride. Okay, now let's talk about writing chemical formula. So we know about, we studied about elements, okay, and we study about compounds also. Okay, we talked about ions also, either negatively or positively charged. Now with all these three, okay, we can formulate a formula for chemical reaction. So a chemical formula of a compound is a symbolic representation of its composition. Okay, the chemical formula of different compounds can be written easily. Okay, so let's have a look. The combining power or capacity of an element is known as valency. So we need a valency for that also. What do you mean by valency? It is a combining power of an element, means how it will combine. Okay, so a valence of atom of an element can be through an thought of as hand or arms of an that atom. Let's take an example that has been mentioned here. Human beings have 2 arms, as we all know, and an octopus has 8. Okay, that means it is an example of hydrogen and oxygen. Okay, so if one octopus has to catch hold of a few people in such a manner that all the 8 arms of octopus and both arms of all the humans are locked, how many humans do you think the octopus can hold? Represent the octopus with O and humans with H. You can write a formula for this combination. So do you get OH4 as a formula? The script 4 indicates the number of humans held by the octopus. Okay, that means it was all to explain. Okay, now let's move. So now we will have a look at a name of an ion and its symbols. Okay, so potassium, sodium, potassium, silver, copper. Symbol is sodium Na, potassium K, silver Ag, copper Cu, and we have an ions, that means plus, plus, plus and plus. We have negative also some way, as for example here in iodine we have negative, in chlorine we have negative, okay, hydride we have negative, and in some cases there are more than 2 ions. Okay, so in nitrite, not nitrate, nitrite have sodium 3 minus. So a chart has been given where this valency and ions has been mentioned. So there are certain rules that must be followed while writing chemical formula. The valency or charge on the ions must be balanced. That means all the valency, if it is on left side is 4, on right side it must be 4. Okay. Then when a compound consists of metals and non-metals, the name of the symbol of a metal is written first. So for metal we have to write first. As for example, iron is a metal, okay, and sodium is a not non-metal, so we have to write so iron first, then sodium. Okay, let's have an example. Calcium oxide. So calcium, then oxide is similarly sodium chloride. Iron sulfide. Okay, so iron first, then sulfide later on. Okay, so in compounds formed with polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of an ion in a bracket. That means this one, magnesium hydroxide. Okay, MgOH whole 2. So in case the number of polyatomic ion is 1, the bracket is not required. Because it is 1, so bracket is not required. Sodium hydroxide. Okay, so formula of a simple compound. The simplest compound which are made up of two different elements are called binary compound. Means there are two elements, so they are called binary numbers compounds. Okay, valences of some ions are given in table 3.6. okay, that we have observed in a few minutes, a few seconds back. So while writing chemical formula for compounds, we write the constituent element and the valency as shown below. Okay, let's have an example. Formula of hydrogen chloride. So hydrogen symbol is H, chloride means chlorine symbol is Cl. So valency is 1 1. So the compound formula for the compound would be HCl. Okay, hydrogen chloride. Then hydrogen sulfide in the similar way, H and S. H valency is 1 and sulfide valency is 2. So that will be crossed. The formula will be H2S. Okay, valency we will take other elements valency. Okay, similarly we have other examples also. CCl. Okay, so CCl4. Understood? Because carbon valency is 4, chlorine valency is 1. In the similarly way, more examples are there with ions. Okay, Al2, Al have 3 positive ion and oxygen have 2 negative ion. So formula will be Al2O3. Okay, similarly here also Ca 2 plus and O2 minus. So the valency of the two elements are the same. You may arrive at the formula Ca2O2, but no, we can simply write CaO because these 2 and these 2 will be correct. Okay, so simple formula will be CaO. So we have more examples here, sodium and nitrate. Okay, so 1 plus 1 plus. So we don't have to write 1 and 1 because 1 and 1 is already there, but these 3 is of nitrate. Okay, because here oxides have 3. Then formula for calcium hydroxide, CaOH. Okay, here OH, in O is 1 elements and H is 1 elements. So we have to write in a bracket because these two valency is for O and for H also. Okay, so we have to write bracket. Look here, formula of calcium oxide is CaOH2 and not CaOH2. We use brackets when you have 2 or more of the same ion in a formula. That means if you keep like this only, hydrogen have 2 molecules. Okay, so here the brackets around OH with the subscript 2 indicates that there are 2 hydroxyl OH, 2 OH, not H or not O, there are 2 joined to one calcium atom. In other words, there are 2 atoms each of oxygen and hydrogen in calcium oxide, as I told you. Okay, that means if 2 is indicated, 2 is for oxygen also and 2 is for hydrogen also. Okay, so we have more formulas here, sodium carbonate, ammonium sulfate NH3, NH4 whole 2 SO4. Okay, so we have to be more careful with these brackets. Okay, so we have few questions here. Okay, so we will talk those in later class, and this was all about atoms and molecules. So in our next class we will talk about molecular mass and mole concept. Till now, Thank you.